Hello YouTube, and welcome back to yet another video in this series of crazy electronics projects videos. So I got this today from PCBWay. This should hopefully be the final version of the user port interface plus a little conversion board because I actually want to start using a different connector standard between the APU, the Advanced Processing Unit board, and the user port interface. I want to have something which is a little bit easier to plug and unplug, because the current version of the user port interface uses those very long pin headers. So I'll show you what that one looks like first. That's the interface board. Where is the user port board? Okay, that's one that's partially assembled. These are the PCBs. We don't want those. Well, we do, but not right now. Let's get rid of the box. There we go. Let's put everything back in the box that we're not going to need right away. Those are also the PCBs. Oh, and I've got some loose components in there too. That's right. So let's get this one opened. There we go. So this is the partially assembled user port. No, this is the fully assembled surface mount version of the user port interface. Oops. Yeah. This is my hopefully final iteration of this board. This basically fixes the little missing wire, which was for the 8 bits external write signal from the Commodore 64. It was probably pin this one here. So it was missing, so none of the logic was actually detecting that bits were being, or bytes were being written from the Commodore 64. So this is the final iteration. You'll notice that it's got this new connector on the bottom, and I'm hoping that it's the right way around, because the other versions of the user port interface use this kind of like these pads here, these holes here rather, pads, use the very long pin connectors. They look like this. And these are very difficult to connect and disconnect, and I'm getting tired of trying to use that, so I actually want to start using this. But to be able to use this on the bottom, the idea is that this on the bottom here will plug into the APU board as the daughter board, or optionally it can plug into the backplane, so that then I can use the user port interface directly to the backplane, which then exposes all of the memory bus here, the 24-bit address, 24-bit memory bus for the address, and then 8 bits for the data, plus the write signals and stuff like that. So then I can just plug it and unplug it very easily using this connector instead. Now, to be able to convert from this long pin header, or 3 of them rather, to something more sensible like the plug underneath, then I'm going to use a little conversion board, because I don't really want to remake the whole APU board, because it's, quite large, quite expensive, and there's no real need if I can just plug in this instead. So if I move that over there out of the way, then open this up, you'll be able to see what I mean. go. Being careful not to cut anything that I don't really want to cut, of course. Here we are. And you can see here the long pin header here, which hopefully, if that's coming through, the long pins here that they plug into the APU or they plug into the backplane, you see. So what I want to be able to do is that I want to be able to plug this in to the existing headers, which expect to get these long pins, right? And then I want to be able to plug this new version of the board into here like this. It's basically a converter board, so it plugs in quite snugly like that, and I can quite easily unplug it again. And this just makes it easier now, hopefully, for me to update this board or to disassemble it and then reassemble it again. A nice solid connection here, which is very nice. Anyway, so I just need to make sure that, say for example, this header here, the orientation as it is at the moment, top right should be plus 5 volts, and of course there should be continuity from going down into here as well, because this is just a mirror of this connector here. I'm not going to populate this one if I can help it. I'm hoping that this connector and everything else will just work properly as expected. And then if I plug it into the APU, because the APU board is vertical on the back plane like this, then the long pin headers here plug into the APU board like that. So then this daughter board here then goes into this daughter board here, and then it should just sit. This board should sit very parallel to the APU board. It's slightly taller, wider, if you like, than what it should be if I just had this socket on the APU board, because it should be, you know, like this on the APU board. But you know, the APU board is the last one in the stack currently, so it's not too bad, I'm hoping. So anyway, if I connect this together, then ideally if I check the continuity, and let's just do that now, then I should get continuity from, oops, let's get untangled, shall we? There we go. Still tangled, still kind of tangled, there we are. Okay, so I should get continuity between top right and the top right of the IC. There we go, and there shouldn't be anything to ground. And if I go top left of this here, then there's continuity to ground, and there's no continuity to top right of the IC. This IC here, U9, is just, you know, typical. So let's put that just back in there temporarily. There we go. Of course, I've grounded. Now I just need to double check that the continuity here is good, which I'm, you know, 100% sure it is. Oh no, yes, it should be. Should have continuity. Let's just try that again. No. Okay, I'm not getting any beeps. Why am I not getting any beeps? Probably because the plug came out. There we go. Let's try that again. Boink. There we go. Boink. Yes, and then ground. 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 No. Good. Okay. So I think that indicates that if I now solder up this to add the rest of the sockets here as expected, and then plug this into the APU and then plug it into the Commodore 64, it should just work, as long as this board is still fine. And the previous iteration of this board was fine once I put a bodge wire from here into one of the inputs for, I think it was a latch or something like that, or a flip-flop or something like that, same kind of thing. Anyway, so let's get that soldered up and hopefully it will work. going to unplug this while I'm working on soldering it up. There we go. Let's put that out of the way there. Let's get tidied up. There we go. These are the ones which came through. Okay, there we go. So you'll notice that one's been soldered in already. The other one didn't. I just asked PCBWay to send me these loose, and then I will solder them in later on. Oh, actually, let's just have a look at this board. This board, as you can see, looks okay. Let's just have a look at it under magnification. You're probably not going to be able to see this, but I am, and of course everything looks nice and hunky-dory and everything looks good. I can see all of the tiny little decoupling capacitors, and I'm very glad that I don't have to solder all of this in. I don't see any solder bridges or anything like that, as expected, right? You wouldn't expect solder bridges and things. Let's just double check the very smallest ones. You see, this magnifying glass here has got two lenses. It's got the small lens in the middle, which is a much higher magnification. My word, this is such a tiny little surface mount device. These ones here. U12 on the schematic is tiny. It's almost as, well, it is. It's actually a very fine pitch. It's a much finer pitch than the other ones. Hurts my brain just to look at it, to be honest. Yes, it is actually, for reference, it isn't LSO4, 74 LSO4. It's a 47K G480F from Texas Instruments. Tiny little thing. Lovely it is. Anyway, let's put this away. It looks all fine. Actually, let's look at the reverse of the board. The reverse of the board also looks nice. But they even soldered this one in very nicely too. The power socket, which actually I'm not using because the backplane has a nice. It has a much better power delivery method, because the backplane is built to actually handle higher current loads than this little one here. So actually this board draws power from the APU, which draws power from the backplane. This looks all fine, and all of these through hole connections also look very well soldered. Thank you very much, PCBWay. Yet another, obviously, very neat job. Looks like it will work first time without any problems at all. Very happy with it. Let's put that over there. Let's start populating this and then solder it up. See, PCBWay order from Mouser as well. So PCBWay is great. Inside the BOM, the book of materials file, which I send to PCBWay, the BOM contains links to Mouser, which is my preferred component supplier, and they just fantastically, they just order straight from Mouser, and then they just assemble them in the factory. Now I'm hoping that I ordered the right parts. Did I order parts? I don't know. Let's have a look. Isn't it? Wouldn't it be funny if these ones don't, although they don't fit? Ah, that's what the problem is. So the turned pin versions of these, that's where the problem was. I see. These ones are a bit wider. The turned pin versions of these that I had actually fit side by side. I see. So what am I going to do about that? Well, I'm just going to have to, I don't know. Let's see, if I put these ones side by side, they're probably not going to fit either. So that's the problem that PCBWay had, was that these don't fit, you see? Yeah, the turn pin versions fit side by side. Hence why PCBWay couldn't assemble them all. I mean, there's this one here which goes in. Obviously I ordered the wrong size of that one too. Let me see. Do I have any of those longer turn pin ones left? No, I probably don't. No, look, see, I don't have any. Let me have a look through the rest of my collection. Sounds of rustling going on in the background. Look what I found. There we go. I found my collection. So my other collection of turned pin long sockets here like this. See, these ones still fit. Right, boink. They can fit, no problem. In here. Actually, it's very snug. I'm not grounding myself because this board doesn't have any components on it. Any active components anyway. So you see here, right? They actually fit quite nicely. But, so, these ones here, they can go in like this, or I can choose some shorter ones. Pretty sure I have some shorter ones in here somewhere. I've got a collection, you see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10s, or I've got 1, 2, 3, 4, 5, 6, 7, 8s. Of course, it's one extra. Or what I can do is that I can maybe use 8s, and then a 1 down on the end. Maybe if I wanted to, I could split this one apart because it's 2 and a 2. So there would be a 2 on the end here, and then 2 on this here. Rather than chopping up some of these other ones, which, yeah, I don't really want to do. These are precision dip headers, you see, with wire housings. I'm going to have to order more of these. Luckily enough, it's from NASA, so I can look back at my order history and I can check. So anyway, let's see if I can. Do I have? I don't have, do I? Oh, I do. I got this one here. Because this one I don't think is going to cut very well. This one does cut better because it's got this groove here. Here we go. There's a couple of ways of doing this one. It's actually quite hard. Oops. Plastic. So I need to be a little bit careful. But I think I'm going to try and destroy the one in the middle. Like that. There you go. And then remove the middle pin. Don't really need this anymore. Don't really want it floating around anywhere in the bits box where it can scratch, so I'm going to remove that. So there we go. I put this one in here like this. This one in here like this. There we go. And then I can put in a bunch of these here like this. And then one more in here like so. So then you can see I got this here. Oh, you see this one's longer. I might have to trim these. Don't really want to have to do that. And if I'm lucky enough, these ones are also soldered into the APU board actually. So I think it would be long enough. Although I might just trim these off. Should be fine. Ding ding ding. This is what happens. You see, this is precisely why I want to stop using these and start using this method of using a connector. Actually, I'm going to trim those off afterwards. First, what I need to do is I need to tidy up, put all of these back. There we go. Dum, 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 dum. I got the 2-1 here that I cut up. So I've done this a few times actually, cutting these. There we go. Let's put these off to the side. Don't need them anymore. Put these off to the side as well. Also don't need those. Right, let's get it taped up. This is where I hope everything is straight. Okay. Start soldering this up. Doesn't matter if they're not perfectly straight because I can alter the alignment after they're soldered. Soldering iron is up to temperature. I'm going to use my magnifying glass because my eyes are dim, they cannot see. And here we go. Trying to focus on the pad rather than trying to focus on the pin pointing up at me. You can say, Martin, you've done that one already, and I'm going to say, yeah, I know, but I don't think I put enough solder on there to actually flow properly. There we go. Let's put it that way round. Oop. Soldering these is actually quite difficult because they're so long. It takes quite a bit of heat to actually heat them up to the extent that the solder will flow properly. Luckily enough, the iron is temperature controlled, but even so, it's quite tricky to get just the right temperature. Basically letting the flux do its job, which you're meant to do. When I get to see the temperature properly, I can see the solder, which is already on the iron. I can see a very thin layer travel up the pin, or I can see discoloration of the pin as something travels up. It might indicate that the pin itself has a plated, tinned layer, perhaps. I think it's probably heat effects or something like that. Maybe it's the heat evaporating something that's on the pin. I can see it going up the pin like that. Okay, so that's that end all soldered up. There's that side all soldered up. Just let me check for solder bridges. there aren't any. They all look pretty good. 1, 2, 3, 4. 3 along from the last one. Doesn't look like it's quite flowed properly. 3 along from here. 1, 2, 3. Let's just apply a bit of heat. There we go. That's causing it to reflow now, and then that should be fine. Good. There's flux residue, but there's no solder bridges. Do the same for pins on the other edge. So here we go. The thing is with this, you need to be able to relax your eyesight a little bit when you're looking at this, so you defocus and you're actually focusing. You're using the magnifying glass pretty much to do the focusing for you. I can hear my daughter downstairs. She probably doesn't realise that I can hear her open her door and then go downstairs. I bet she's gone to the kitchen to go and get ice cream. Because we had dinner a little while ago. There you go. Did you hear that on the video? I don't know if it came through on the video, but I just heard what sounds like a metal spoon dropping on the floor, on the tile floor of the kitchen downstairs, 2 floors below. Quite funny. I expect she was trying to be all sneaky and surreptitious and dropping the spoon on the floor. It's just basically sounded the alarm for the ice cream. It's nice ice cream. I think it's Ben & Jerry's. Something like chocolate fudge or something like that. Very nice. To be honest, a bit sweet for my taste, but she seems to like it, which is fine. I wonder if I'm going to get ice cream. Do you think I'm going to get ice cream? I don't know. She probably thinks that I'm upstairs doing work. There we go. That's that done. Wow. Did you hear that on the video? She just dropped the spoon again. How on earth can she drop the spoon twice? I mean, once is, you know, like, okay, twice in a row. Ooh, did I forget to? I did. I forgot to solder those two. How silly of me. Okay, so it's ding ding ding. These ones here. That's funny, isn't it? Okay. That's the power of ice cream, you see. The power of ice cream made me. Oops. The power of ice cream has made me forget to solder these 2 pins. Here we go. There's one. Let's just make sure it's flowed correctly between there. And then this one here. There we go. Boink! I saw that plop over. There we go. Let's just double check that I've really soldered all of them this time. And I haven't heard any more dropped spoons in the kitchen. There we go. That's soldered. That's soldered. That's soldered. Is that? That's just flux residue. Let's use the soldering iron just to try and burn off any remaining flux residue between these ones here. And these, well, not burn off, but you know, evaporate slightly, I guess. Here we go. Ding ding ding. That's better. You see the solder resist on this. You know, actually the solder resist on PCBWay boards tends to be really good at resisting solder, which is, you know, what you would hope solder resist does, probably, right? And of course the flux does its job of helping to reduce the solder bridges. Everything else looks hunky-dory. Hello, my darling. I heard you drop a spoon on the floor twice.
Yes.
Was that because you were getting ice cream? Tee-hee. Tee-hee indicates a response to the affirmative, right?
Like, am I not be right either?
Huh?
Anything I'm wrong? Like, am I not be right either?
Yeah, I'm not wrong and I might not be right either, but really, okay. So it's not just ice cream, it's something else as well then.
More like creamed ice.
Creamed ice. Creamed ice is ice cream, is it not?
Creamed ice.
Creamed ice. Okay, now I've soldered this, I'm going to trim these off. That sounds, you know, just the same as ice cream, to be honest. I can hear biscuit or something. Did you not get me a biscuit? This is deeply unfair. Is that a biscuit or is it chocolate? Bảo bảo,
Yeah.
你有没有功课？你有没有功课？
没有功课。
没有。
Yeah, 没有。
哦，真的吗？That went pinging off somewhere. That could be not too. See, I'm trying to cover the pins after I snip them. There we go. Pong, 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 pong. Yeah, they're roughly the right length now. Okay. Okay. That's all that done. That done. Put that pitch like that. Let's let's plug this in here. It's amazing that these two plugs and sockets are in the right way. There we go. Okay. Let's plug this into the APU and see what we get. So welcome back. Now here is the APU board. There it is, version 9.4 APU with the daughter board stack. So here is the expansion bus, DIL to DIN version 1.0 board, nicely plugged into that troublesome edge connector on, well, not edge connector, troublesome header on the bottom. And then it goes into that nice plug socket arrangement there, the DIN plug socket arrangement, which then goes into this new board here. You'll notice that this new board has a couple of fewer chips than the previous iteration of the board, and also this board, the previous iteration, has a bodge wire on it. Of course, this board does not have a bodge wire. I remembered to transfer over the clock, the CAN oscillator basically, and all that's left to do now is to plug it in to the backplane and see if it works. And it should still work because this old board with the bodge wire works. You can see how long these pins are, so let's give it a try. So here is the APU board with the new daughter board arrangement now plugged in. You can see here we've got the double daughter board, which is the conversion from the old style to the new style plug and socket for the user port interface. The Commodore 64 is on. The kind of like the default power on state for the graphics hardware is actually good. I'm expecting this. Let's just press A on the Commodore 64 and then we should get fantastic a loading screen and also music. So the music is coming from the speakers, which comes from the audio board here. There we go. Let's press fire. Here we go. And bingo! Fantastic. So everything seems to be working, and actually it seems to be well, there's a glitch or two, but that just means that I still need to debug that APU. Apparently memory transfers from the Commodore 64 through to the user port interface to the APU are still not quite working as intended, but at least it can recover in most circumstances. So let's reset the Commodore 64 again, just to be on the safe side. So there we go. It all works rather nicely, and I'm really quite happy with that. Next step is to finally debug the APU, because there are some memory glitches occasionally from the user port interface to the APU in the internal data memory, which causes some problems later on. So I need to finally debug that. I think I'm not quite solving the memory contention issues in all edge cases, so I just need to debug that a bit more in the simulation, get it reproducible and then fix it. But yeah, generally speaking, I'm generally very happy. The new board from PCBWay works really well. So yeah, fantastic. Thank you very much, PCBWay, for providing yet another working board. Very happy with the work that you do. Oh yeah, one more test that I want to do, just to show you how much the APU is actually rendering. If I turn off the Commodore 64, the music doesn't update, but the rest of the display is actually maintained by the APU. So the APU is running all of this code here to change the palette as it goes down the screen. It's running all of the code to multiplex the tree, which is actually non-scaled, normal sprites. And of course it's updating all of the horizontal scroll positions, because each layer of clouds is a different horizontal scroll position to get the parallax working, and also all of the splits down here. All of that is being maintained by the APU, the Advanced Processing Unit, which is basically like a copper chip, plus a splitter from the old Amiga days. So once the program and once the data for the program is actually in the APU's memory, you can see actually that the APU is running in a very stable manner. So this tells me, from a debugging point of view, that the issue is specifically with the 24-bit user port interface sending memory into the APU, into the internal APU data memory. Because I have left it like this, and it will run the APU code without any issue at all, no problems for a very, very long time. So there is definitely some kind of interference happening or memory contention happening when the Commodore 64 tries to add changes into the APU's internal data memory. I don't think it's interfering with the program memory, because the Commodore 64 does not write any APU program memory once the APU has started executing. It's just the Commodore 64 is only updating APU RAM. I've also debugged this a little bit more, and I've turned off all of the extra music updates and everything else, so all of the updates from the Commodore 64 go to the APU internal data memory. There's no through memory writes into the actual underlying video audio hardware going on. So I'm narrowed it down on the hardware. I just need to narrow it down and reproduce it in the simulation.